Yay, we love free-threaded Python. Or we don't. Okay, let's find out today. I hope at the end of this talk, you would make up your mind whether free-threaded Python is something for you or not. So let's see. Right. Just to give you some background, so we are all on the same page about what's the deal with free-threaded Python, right? Like, is it a buzzword or is it like a real thing? So I'm just going to go through everything together with you all. First of all, how many of you have heard about the phrase that Python is slow? Okay, quite a lot of you. Whether you believe it or not, let's look at why there are these kind of comments every time when we talk about Python, right? Like if you go to other conferences, maybe you tell people, oh, I'm using Python, and they're like, oh, Python is slow. But why? Okay, let's look deeper. First of all, Python have something that is actually quite famous or infamous, which is called global interpreter lock. What is this? So global interpreter lock, if you talk with some kind of other developers, like for example, some C developer or Rust developers, is actually, there is a kind of thing that they call mutex. So what is that? So mutex actually means mutual exclusion. So global interpreter lock, which is, or sometimes we call it GIL, is one of those things. But what makes Python different with the other languages is that Python just use one giant lock to make sure that you can't have multiple threads to access the same Python process at the same time. So why we have this design, right? Like, but why when Guido invented Python, why he did that? So as you may know, Python actually is quite an old language. Python is actually older than Java. How many of you know that? Yes, okay, thanks, Mark. So Python was invented in the 1991. I think some of you sitting here may be even younger than Python. Yeah, because you look very young. At that time, a lot of computers, they are not like our computer these days, right? Like at that time, mobile phone is not the smartphone that we have today. It's like very giant, like all the technology were very, very different. And most of the personal computer, which is just starting to get popular, so some household, they may have a personal computer, and they are actually, they would only have one core compared to today, right? Like if you just go to like, let's say Apple and buy a MacBook these days, you would probably see the spec is like have 16 core or something like that, right? It's totally different. Maybe your phone will have more computational power than a computer back in the time. So at that time, it's acceptable to just have one global interpreter lock to just make the program run on a single thread, because you only have one core. It's like it's not really going to have enough computing power to run multiple threads unless you have a supercomputer in a research center, which I think is not the case for everybody. So at that time, it was actually a very smart design. That's why we have that in Python for a long time. However, of course, later we have all these, data science start to use Python. We are processing a lot of data, which is very exciting, and eventually give birth to AI. So we need more computing power. And at that time, around like maybe 15, 20, maybe 20 is too much, like 15 years ago, we have all these like, data science library coming up, right? We have like NumPy, which is super, super popular. They're actually not written in pure Python. They are written with some binary extension. So it's actually written in C. The reason of doing that is that you can't reach like the speed of NumPy if you just use pure Python to write it. So at that time, some people figure it out. If we want more computing power, if we want like true multi-threaded processing within Python, I just write it in a completely different language, right? I'm not writing it in pure Python. That's how we can have more control of how the program is being processed. So this was kind of a thing in the past, 15 years. However, as now you see, we have more and more kind of new technology. We are just thinking, right? Like the community is actually thinking, right? Can we not have, this limitation in Python? We all want Python to be faster because Python is so popular. We want it to be very accessible to everybody and can achieve more with just a simple language like Python. So, yeah, and also, with all this AI and all this stuff, like we are processing a lot of things. Can we just have like more power? We are wasting all this computing power in our computer that, you know, we are not in the 90s anymore. We have multiple core in our laptop. Can we use those power to the fullest with just Python? So it has been in discussion for a while. There are multiple attempts to remove the GIL, and eventually we have reached that point recently. So right now, the latest Python version that is, released is 3.14, but in the previous version, 3.13, actually, three-threaded Python was already introduced. It all goes to this PEP, which is probably one of the quite important PEP in Python history, is PEP 703. That is actually kind of putting the direction of where Python is going. It's the title of it is like saying making the global interpreter lock optional in C Python. It's a huge thing. The whole community like go crazy about it. So what is like describing it? A lot of things was described in it. It's down to a lot of technical detail as well. But just to give a big overview of what it is talking about. So it states that in the release of Python 3.13, an experimental support for three-threaded mode is supported. So if you use, let's say, UV or other like a PyEnv, you can actually get a three-threaded Python build from 3.13. It's not the default. So if you just like, without knowing this and just get 3.13, it's still the standard version, which have the GIL there, and it's not three-threaded. However, if you specifically want a three-threaded build, you can get it, or you can, compile it yourself by having the source code from the CPython repo. So it started the era of people start trying three-threaded Python, and three-threaded Python become like a term of things. Some people at the very, very beginning call it no-GIL Python, but it's actually quite a bad name because there are lots of nuance in the name. So I think now a lot of core devs, they agree on like, let's call it three-threaded Python. So we would call it three-threaded Python. So together with this PEP 703, there are actually the steering council, which is the leader of the CPython development. They announced that actually the plan is to have three-threaded Python as a default in the future. Wow, it's such a big thing, right? Like, we are changing like a huge part of how Python work. Okay. Yeah, so does it affect me? What has been changed? So let's look at it. Right now, so let's talk about before 3.13, right? Let's say 3.12 to make it more simple. So there are still a standard library called threading. So you may feel that, I can still have multiple threads in Python. What's the difference? So before three-threaded build, the multi-threading in Python actually is not true multi-threading. Actually, you will see it later when I do the demonstration. Actually, the threads are actually still have to pause when the other threads are running. So, it just takes turn to run instead of just like running it truly in parallel. So, by having three-threaded Python, it kind of opened this, gateway, and then now we can have like truly parallel Python there. Which some people really, really welcome this change. Another thing is that if you are developing something, a Python library that have binary extension, you may have to think about whether your code is ready to this new three-threaded build, because if you are writing a Python library that have that, let's say you're written in Rust, uh, if you are a user of PyO3, so that's how usually people get a uh, a Rust program to run in Python. So with PyO3 in the past, it's kind of assumed that the gear is there. So a lot of things that you have to worry about when you are doing some lower level languages to make sure there all these like issues with the parallel processes, like you can just kind of ignore it because the gear is there. There's no problem with that. But now, because your user may be using a three-threaded build, so you may have to take that into consideration. So if you are paying attention to the recent changes in PyO3, then you may notice like this is a big thing that affect how it has been changed drastically in the few recent versions. Also, if you're developing a library that use binary, you will be writing a lot of code that talk with this C API, which is how C Python kind of communicate with your binary extension. So now, because this three-threaded build will have some new API, so like you may have to use new methods when you are writing a binary extension for your Python code. So what is next? What should I do? This is quite new and quite exciting. For some of you who just like, I'm just like using Python as a thing. I don't actually look into binary extension. I'm just using pure Python. I just code. I don't actually need multi-threading. Then maybe you don't have to worry about anything, because it's fine. Like all these changes won't actually affect you or your program. So you can just like business assets. Maybe some library will be faster, but I don't have to worry about that because someone makes sure that it works okay. However, if you are maintaining some libraries that, like I said, have binary extensions, and you are doing all these like kind of lower level kind of coding things and need to talk to C Python, then you may have to look into the technical detail. That there's a lot actually now since the PEP 703 has been announced. There's a lot of technical documentation that is done by the core developers, so you can look into actually what had to be changed and like how you can migrate to a three-threaded build. And because of the announcement made by the steering council, like I said before, so right now we are actually in phase 2, which is 3.14, which means that now the three-threaded build is not experimental anymore. You can probably use it in production without major issues. So that's the phase 2. But phase 3, which is the next phase, we will be having it as a default. So you don't have to specify saying that it's a three-threaded build. It will just be assuming that the newer version of Python is a three-threaded build. We don't know when phase 3 will be started yet. There's no official announcement yet. Some people speculate it's going to be next one, 3.15, but some people, but there's no official answer, so we don't know yet. So if you know any core devs, you may, try to chit-chat with them to see if you can get some insider information. I don't, so I can't tell you. However, this will be the future. So one kind of big point of, are we going to just make three-threaded builds as a default? Are we ready yet? Like I think one of the big discourse in that is that Python is not very useful if we don't have all those like amazing Python libraries on PyPI, right? So how many of those libraries are actually three-threaded ready, right? Because if we use a three-threaded build of Python, then we may as well use library that support that. So there's this, website by the release manager of Python 3.14, Hugo. You can see the link there. If you go there, you will see the most updated, because it updates daily, the wheel, which is like here, this colorful like green and yellow wheel that you will see there, which indicates how many libraries out of the most popular, like 360 libraries, how many of them are actually having a free-threaded will that is available to use together with free-threaded Python. It's also this information that I get is like, last week, so I don't think it changed drastically as of today. So around half of them are actually ready, so it's not bad. But still, the other half are either they are a pure Python will, but they are not. It's not compiled for free-threaded Python yet, or if they are like, they have wills, but they are not compatible with free-threaded Python yet. So half of them actually work, half of them not yet working that well yet. So I think we are kind of quite far away from it's ready, in my opinion. So this is something that may affect some of you who actually want to use the power of free-threaded Python. So let's say if you want to have a look at all of you, let's say you want to migrate to use free-threaded Python, right? If you want to check whether the library that your project depends on, whether they are compatible with free-threaded build, how can you check that, right? Because it would be very weird if it doesn't maybe it doesn't work as expected. So you better check. To check it, the easiest way, as always, go to PyPI, have a look at the page that describes that library, right? Like I always recommend people to have a look at the library, before you even install it, because you better understand what you're installing before you install it, right? That's always a good practice. So have a look. You will see that if it's free-threaded ready, it should have a tag there on PyPI. On when you look at the page on the left-hand side, it should have a tag there. However, sometimes we are like, oh, but it's kind of I don't have that much time. I just want to look locally, look at the library. So what you can do is that let's say you have a VN, you can just look at what's inside your VN, right? You will see that the will that it will store inside your VN folder, .vn folder. Usually it's called .vn. If you look inside it, look at the will of your library. It will have a very funny name that have some hyphens in it. Those are actually the ABI tags. So one of these tags should have something like CP314T, which means that is compatible with CPython 3.14 threaded, free-threaded build. So that's what the T means. So if you spot that, either 3.14 or 3.13T, that means that is compatible with that Python, and you have downloaded that. So this is another way to just have a peek at your local files. Another way that if you have more time, if you are more curious, or you want to contribute to that library, you can try it yourself. You can, a lot of the Python libraries, they're open source, they're on GitHub, so you can just get the source code, compile it yourself with your free-threaded Python build, which you can easily obtain with UV or PyEnv, or even build it yourself. I would show you some link of some more information there. You can have a look at how you can test free-threaded Python. If you find something that is weird, or you actually, again, you really love this library, you're trying it, you found something that could actually be improved to make it works better with the free-threaded Python, maybe think about contributing to the library, because the more, remember that the more green we have, the better we are ready for free-threaded Python, right? So we can all do something to help our community to move into the future. But you may have a question in mind. But is it really for me? Do I really do I really care about free-threaded Python? Is it really going to help my project? So there are a few things, right? If you're kind of new to the concept, you have to think about whether you need it. So, for example, if your code have a lot of CPU-bound processes, or for example, you are handling a lot of data, um, for example, you are scraping a lot of things from the internet, or you are doing some like machine learning thing like Monte Carlo stimulation or training machine learning model, then yeah, you are doing a lot of CPU-bound processes. And if you are not already using a library that is written, in other language that do this kind of, parallel processes, then maybe free-threaded Python can help you. And also, like if all your dependencies are ready, so fun fact, if you have a library that is not free-threaded ready, and if you use it in a free-threaded build, what happens is that the guild may be like, oh, actually your library is not ready, it's not safe, so I'm coming back in to protect you. So the guild will come back in. So you will see a warning, so the warning will be printed out, and then you see that, oh, actually, I'm not doing three-threaded Python because the guild is coming back in. So, so your code will still be fine, but you are actually not having the advantage of the free-threaded build if some of your dependencies are not ready. However, it's it's not always good to have a three-threaded Python. It's actually make it harder to code if you are dealing with these true multi-threading things, because now a lot of programming pitfall that the other programming languages have to deal with now come into the picture of Python. For example, deadlocks, mutable data. You may have to change it to atomic design, so and thread safety, race condition, all these things that in the past we don't care because the guild protect us from. Now maybe in the picture of what you're doing, and it's not always faster. Like if you just think that you can just change your code in a three-threaded build and everything will just go faster, that's actually not the case, because if you do this multi-threading things, there's an overhead because there needs to be a manager to manage all this thread, like when does it run and all this, and also your change of the design to avoid all those mistakes. It will give you some kind of overhead for your performance. So it's not like, oh, I use 5 threads, so it should be 5x increase, right? No. So one way to check whether your code actually speed up is to actually profile your code. This is actually very important because a lot of people, coders, that they actually don't really care and don't profile your code. So what I'm going to do is to show you this. So this is, can you see it? I can make it bigger maybe. Okay. It's a bit stressful when it's like, okay, appearance, let's make it even bigger. I can make it super big. Okay, 200 should be fine. Okay, so this is just a example program. It's doing something silly. It's just doing some multiplication. It will spawn 5 threads, and then each thread is doing some kind of crazy multiplication here. So it's quite CPU bound. So what we can do is that in the free-threaded guide, which again, like the link I will show you later, it's suggesting we use the Samply, which is a tool that you can do profiling on a multi-threaded program. So in PyCharm here, I've hooked up the Samply. Of course, you have to install it. According to the guide, you install it, and then I hook it up with a run script. So when I run it, it will run the Samply profiling, run the profiling for it. So let's say now, let's double check. Right now, I have 2 interpreters set up here in my PyCharm. So the .vm, this one, is actually using a standard build. So it's not a free-threaded build. So let's do a sampling and see what happened here. Right, so now I'm running that because I've set up the run script. And 5 workers are working. So you will see, wow, this is quite a lot, right? But don't worry too much. Just pay attention to the top part of the graph. Can I make it bigger? Yeah, okay. So pay attention to the top part of the graph. You see that there are little spikes there. So this is actually showing you that the different threads, they are actually taking turns to process. So you don't see that they are running actually at the same time. If you like really zoom in, that you see like maybe this thread is running, the other threads are not running at all. However, if now I switch the, let me close all of this first. Okay, terminate and close. And let me switch to the other interpreter, right? So let's switch to this one, which again, double check to see which environment I'm running. I'm running the .vm-t. This one, I use a free-threaded Python. So let's do a little bit of profiling. Again, like it seems faster. I can show you the number, but let's skip over it because but it actually is a little bit faster. And you can see the graph here. Everything is like those spikes disappear, and everything is like running at the same time a lot of times. So this is kind of a sign of showing you that actually you're doing true parallel processing. And again, like you can dig into it. How much time does it cost? Is your program actually faster in general and all those stuff? So profiling, super important. I again like recommend you to check the documentation of where does my presentation go? No, not here. Okay, I know. Is it? I can't find my presentation. Okay, this. Where does it go? Okay. Anyway, I lost my changes. Is it here? Maybe it's here. Oh, I know, it's here. Yes, I found it. Right. So yeah, I recommend you to actually profile your code with different builds. It's bonus if you are using an IDE like PyCharm that lets you do multiple interpreters and set up the run script. Yeah, so make sure that you are actually taking advantage of a free-threaded build. So last thing, I'm running out of time. Takeaways. So free-threaded Python is actually the future. It will become default sometime in the future. I don't know when. But if you are just like, I'm not using multiprocessing, this is like, I don't really care about it, it doesn't help me, then you're fine most of the time. I mean, I can't guarantee you, but I am pretty sure that you will be fine. Everything will still work, so it's fine. However, you may want to learn more about it because it may actually help your code to either speed up, or maybe you have some bottleneck in your code. This may be the solution for it. So learn more about it. Again, next slide will be all the resources. You may want to have a look at those to learn more about it. At least you know when you need it, where you go to find information. Another thing is join the discussion. There's still, it's still something very new, and a lot of developers are still figuring things out. Just go there and talk. And if you have a use case, you can actually share with others. So in the useful resources, the pyfreethreading.github.io, you can actually share your use case there as well. So yeah, you can I highly recommend you check out all of them, at least skim through it. Then when you need to use free-threaded Python, where to look for the information. There's also the QR code for this slide deck, so don't worry if you're like, oh, it's so information heavy. Well, you can have that. It's fine. Right. Okay. Can I? Okay. Right. So that's it. Thank you so much. Last thing I want you to help me is to fill in that survey. I want to understand how people kind of develop, today especially with AI and all these things. Just tell me. I'm curious. How you do your work today now, since we have AI. So thank you so much.